Good evening, my dear students. This is Mrs. Sohair Zaki, and we are going to start our curriculum for Prep 2 students for the second term. Let's start. Our first lesson in the first unit in our science curriculum is with the title Thermal Changes Accompanying Physical Changes. Our lesson objectives, and by the end of our session you will be able to learn about how to define hydrated substances and anhydrous substances. And you are going to learn how to distinguish between exothermic dissolution and endothermic dissolution. Also, by the end of our lesson, you will be able to follow safety precautions when diluting concentrated acids. At the first, let's take this short introduction. In our daily life, we notice that some processes make things hot while others make things cold, even though no new substance is formed. The figures here shows the evolution of carbon dioxide gas from a fizzy drink when the container is opened and poured. In our lesson, we will explore the ideas that will help you answer the question below. Is the release of gas from a solution considered a physical or a chemical change? Also, you will be able to this question. Does this change occur by releasing or absorbing heat? And why do we feel cold and refreshed when drinking fizzy drinks? At the first, we will learn about the thermal change during daily life. And we will do a very simple experiment here. When you're rubbing hands using laundry powder and water, what you will feel? You feel warm. You can do this experiment under the supervision of your teacher or your mom, even in your home. Let her put in your hand some of her laundry powder and mix it with a small amount of water. What you feel? You will feel warm in your hand. The reason of this feeling is that heat is released during dissolution. This process is exothermic process, where heat is released during the solution. Let's learn more about thermal change during daily life and do another simple experiment. We can do it at home. When rubbing hands using antiseptic hand gel, in our homes we have antiseptic hand gel or even a small amount of alcohol. Use a small amount and put it in your hand. What you will feel? You feel coolness. And why? The reason is that heat is absorbed from your hand. This is the other case in which heat is absorbed from our hands, and so this is an endothermic process. Let's conclude what happened in our previous simple experiments that we can do in our daily life. This dissolution may be accompanied by thermal change, either absorption or release of heat. Let's learn this cumulative knowledge. Processes of changing states of matter include melting, evaporation, freezing, condensation, sublimation, and deposition. All of these are reversible processes that don't involve breaking chemical bonds or forming new ones. So they are reversible processes. What is meant by reversible processes? This means that the substance can be returned back to its original state. For example, by talking about melting of ice. Melting of ice is the changing of the ice into its liquid state, which is liquid water at 0 degrees Celsius. By freezing, this process can be reversed by changing the liquid water into ice, which is the original state in this case. By freezing, by lowering the temperature, the water refreezed and changed back to ice. And so each of these processes. Thermal changes accompanying changes of state. All changes of a state of matter and the processes of dissolution are physical processes. So let's remember that all of these processes are physical processes that all accompanied by either absorption or release of energy. So energy is absorbed in case of endothermic process or released in case of exothermic process. So these processes accompanied by either absorption or release of energy to or from the surrounding medium. Let's learn at the first about exothermic changes of state. Heat is released to the surrounding medium. This is the main point in exothermic change. Temperature of the surrounding medium increases as heat is released to the surrounding medium. The temperature of the surrounding medium, of course, increases. What else happens during exothermic change of a state? The examples of the exothermic changes of state is freezing, which is the change from the liquid state to the solid state at the freezing point. Also the condensation, which is the change of the gaseous state of a substance to the liquid state by cooling. This is called condensation process, and both of them are exothermic change in which heat is released. Now let's learn about the endothermic changes of state. Endothermic changes include heat absorption. So heat is absorbed from the surrounding medium, and so temperature of the surrounding medium decreases. Like when we use the alcohol on our hands or antiseptic agent on our hands feels cold because the temperature is lowering as the heat is absorbed from our hands. Examples for the endothermic changes: the melting process from the solid state of the matter to the liquid state of the matter. Also, the evaporation from the liquid state of the matter to the gaseous state of the matter. Both of them the matter need to absorb energy to cause this process, which is melting or evaporation. So we need heat to allow this process to take place. Now we are going to learn about one of the most famous technological application on the thermal changes. It's the refrigeration cycle. This is a refrigeration cycle inside the refrigerator. It's a closed and repeated thermal process in which heat is absorbed from inside the refrigerator and transferred to the surrounding. Let's learn more how the process takes place inside the refrigerator. Here are the stages of refrigeration cycle. We will start with the first stage, which is expansion and evaporation. The liquid Freon passes under high pressure through the narrow valves, changes into cold gas, absorbs heat from the food inside the refrigerator, which is an endothermic process. So this is the first stage in which liquid Freon that passes under high pressure in the valves changes into cold gas. The cold gas absorbs the heat from the food inside the refrigerator to be cool and healthy. And this process, of course, is an endothermic process. The next stage is the compression. The compressor draws the gas and compresses it so its temperature rises. This is the second step, the compression of Freon, so its temperature rises. The third stage is the condensation. The hot gas passes through the pipes networks located behind the refrigerator, so it cools down, turning into a liquid again. And this is accompanied by release of heat to the surrounding medium. Those make process exothermic process. And so the gas returns once again to the liquid, and the first step will start again, and the cycle remains repeated again continuously. So this is how our food remains cold and healthy inside the refrigerator, by changing in the states of the matter inside the refrigerator, which is the Freon gas, which changes from the gaseous state to the liquid state, then from the liquid state to the gaseous state again, and so the heat is absorbed from the food and the food remains cool and healthy for us to be eaten. So what is important? It's very important application in our life, the presence of refrigerator in each house and in each place. Its importance: cooling the food inside the refrigerator by continuously transferring heat from inside the refrigerator to the outside surrounding. Now we are going to do an activity. we will need some materials and tools. Let's explain these materials and tools together. We are going to need water, solid sodium hydroxide, solid ammonium nitrate, heat insulating polystyrene cups. This is the cup that we will need. Also, we are going to need graduated cylinder, laboratory thermometer, this is our thermometer here, and sensor balance. Let's talk about the steps of our experiments. The first step, we will place 100 ml of water in the polystyrene cup. The second step is recording the initial temperature by using the thermometer. The initial temperature is T1. So we will record the initial temperature of the water using the thermometer, and we will go to the next step. The third step, add 4 grams of sodium hydroxide to the cup and cover the cup with the lid and stir gently using the thermometer. After 15 seconds, record the final temperature T2. So we have the initial temperature, the temperature of the water at the beginning of the experiment, and the final temperature T2, which is the temperature of the water after adding 4 grams of sodium hydroxide and stir the hydroxide in the water, and after 15 seconds, this is our T2 temperature. So, what is the observation that we observed from recording T1 and T2, and which temperature is greater, T1 or T2? We will repeat the previous steps using 8 grams of solid ammonium nitrate. So we will start by adding 100 milliliters of water and record its temperature, which will be T1. Then we will add 8 grams of solid ammonium nitrate and cover the solution with the lid and stir it carefully with the thermometer, and after 5 seconds we will record the temperature of the solution, and this temperature will be T2. What do you conclude from this experiment? How can you increase thermal insulation when performing this experiment? Thermal insulation means the prevention of the heat from transferring from inside to outside, or the reverse. So how can we increase the thermal insulation? Let's learn how to do this step and what is our conclusion from this experiment. At the first, the dissolution of some substance such as sodium hydroxide, calcium chloride, sodium carbonate, and anhydrous copper sulfate in water leads to raising the temperature of water. So T2 will be higher than T1, because when we add sodium hydroxide, for example, to the water and stir it, the temperature of water will raise up, because this dissolution leads to increasing the temperature, and this dissolution is an exothermic process. The physical change of dissolving a substance in water, which is accompanied by the release of thermal energy, is described as exothermic dissolution. So, when the physical change of dissolving a substance in water causes increase in temperature or release of thermal energy, this is described as exothermic dissolution. The dissolution of some other substance, like in case of ammonium nitrate, potassium sulfate, sodium bicarbonate, and hydrated copper sulfate in water, leads to lowering the temperature of water. So in this case, the temperature is lowered, like in case of dissolving ammonium nitrate in our experiment in the water. The final temperature will be lower than the initial temperature. This means that energy is absorbed during the dissolution process. This physical change of dissolving a substance in water, which is accompanied by the absorption of thermal energy, is described as endothermic dissolution. So, what is meant by the heat of dissolution? Let's conclude the definition together. The heat of dissolution is the heat change, which means the amount of heat absorbed or released. Absorbed, like in case of the nitrates, dissolving the sodium nitrates, and released, like in case of dissolving the sodium hydroxide. So the heat change, the heat of dissolution is the heat change when dissolving a specific quantity of solute in a known volume of solvent to form a solution. What is meant by solute? Solute is the substance that you dissolve in water. What is meant by solvent? The solvent, it's the liquid in which you dissolve your solute. So in our experiment, the solvent is the water. And when we add the solute to the solvent and stir it, we will get the solution. So the solution is the solvent plus the solute. The substance whose molecules can bind with specific number of water molecules is known as the hydrated substance. Let's have an example for the hydrated substance. The hydrated substance, like the blue copper sulfate. So the blue copper sulfate is a hydrated substance because the molecules of blue copper sulfate or of the copper sulfate can bind with 5 molecules of water. Each molecule of copper sulfate can bind with 5 molecules of water, so this is called a hydrated substance. Water molecule can be removed from the hydrated substance molecule by heating. When we heat the hydrated substance, it converts to the anhydrous substance because water molecules can be removed and evaporated from the hydrated substance by heating it. So it becomes an anhydrous substance as it loses the molecules of water binded to it. The anhydrous substance can be converted also back to its hydrated form by adding drops of water to it, so it returns once again to the hydrated form. Here are two tables that illustrate the examples of substances which are hydrated. They have hydrated form and anhydrous form. In the first table, we will observe the hydrated copper sulfate that its molecule binds with 5 water molecules. In case of being hydrated, its color is blue. And when the blue copper sulfate is heated, is converted to the anhydrous form of copper sulfate, so it loses the 5 molecules of water and becomes only the copper sulfate without any water, and its color changes from the blue to the white color. Another example is the hydrated cobalt chloride, in which each of the cobalt chloride molecules binds to 6 water molecules and has a pink color. And when we remove the water molecules, it becomes the anhydrous cobalt chloride with a blue color. So these are two examples for the hydrated and anhydrous forms of some substance. Now we are going to learn about one of the most important precautions that we should concern in doing any experiment inside our laboratory, of course under the supervision of our teachers, which is dealing with dilution of concentrated acids. When adding water to a concentrated acid, a large amount of thermal energy is released, causing immediate violent boiling of water, and this boiled water with the acid can be flushed out from our container and cause harms to our skin and our faces. So we must take careful and don't do this step by this way. We must use another way to dilute the concentrated acid. Let's learn how to dilute the concentrated acid in a safety way from the next slide. As we talked in our previous slide, adding the water to the acid causing splashing out of the reaction out of the container, and this causes severe damage to us, to our class, to our laboratory, and to our skin. What we should do when diluting concentrated acids, the acid should be dripped carefully onto the inner walls of the container, holding the water, and not the reverse. So we will add carefully the acid to the water, not the water to the acid. Adding the water to the acid causes violent reaction and violent dilution, and causing splashing of the acid outside the container, and causes severe damage and harms. The correct dilution is done by adding the concentrated acid very carefully onto the inner walls of the container, holding the water, not the reverse, so the water absorbs the released heat without causing any damage. Okay, so this is the right way to dilute any concentrated acid, by adding the acid very carefully onto the inner walls of the water container, not the reverse. Now let's evaluate our understanding and try to classify the following processes into endothermic process or exothermic process. At the first, sublimation of the solid iodine. What is meant by sublimation? Sublimation is a process of changing the solid state of a matter into the gaseous state directly without passing by the liquid state. So the solid iodine will change directly into a vapor without passing by the liquid state of iodine. This process needs energy, so it needs heat, it absorbs heat during this process, so it's endothermic process. The second process in our evaluation and classification of the processes into endothermic or exothermic processes, the condensation of water vapor. This process involves the conversion of the matter from the gaseous state to the liquid state. So this conversion occurs by losing heat energy, so this is an exothermic process. Our next process needed to be classified is the melting of ice. To melt the ice, you need to heat the ice to convert the ice from the solid state to the liquid state. So in this process, we will need to heat. So this is an endothermic process, as heat energy is taken in or consumed or absorbed from the ice to be converted to the liquid state. The next state or the next process is the freezing of water. Freezing process is conversion of the matter from its liquid state to the solid state. So in this case, our substance will lose energy. So it's an exothermic process at which the matter release energy to the surrounding. So water release energy to the surrounding to freeze out and turns into ice. Our next and I think last one is the evaporation of alcohol. Evaporation is the process in which the substance changes from its liquid state to the gaseous state. So the substance here needs to absorb heat energy to change its state from the liquid to the gaseous state. So as the alcohol needs energy or absorbs heat energy from the surrounding, the process here is an endothermic process. Me, Mrs. Sohair Zaki, was with you today under the supervision of the Science Consultant Office. This is our MOE live stream. See you next session, inshallah.